Hello and welcome back to Engineers Olympiad, where learning meets success. As you know that we are doing the numericals of the second chapter of surveying, that's theory of errors in surveying. So let's start. So the question is, this is the question number 1. Question is that two sides and the included angle of a triangle ABC are as follows. A is 123.462 plus minus 0.030 meters. B is 105.235 plus minus 0.020 meters, and included angle C has been given, which is 32 degrees, 45 minutes, 0 seconds, and plus minus 10 seconds. We have to calculate the area of the triangle and the standard error. All right, so let's do this question. A is how much? It's 123.462 plus minus 0.030 meters. One side of the triangle. Second side of the triangle that has been given is 105.235 plus minus 0.020 meters, and included angle C has been given, which reads as 32 degree, 45 minutes, 0 seconds, and plus minus 10 seconds. All right, we have to calculate the area of this triangle along with the standard error. All right, so let's do it. As we know that area of a triangle is given by, it's 1/2 of AB multiplied by sine of included angle, let's see. One side multiplied with the other given side multiplied by the sine of the included angle that has been given. All right, we know that, let me do it here. Our angle C is how much? It is 32 degrees, 45 minutes, and 0 seconds. All right, so if I may like it to convert it to radians, let's convert it into radians first. We know that 360 degrees, one complete rotation, in sexagesimal system, they are 360 degrees. All right, the system which we commonly use in our country, that's India, the sexagesimal system, already discussed in chapter number 1. So in 360 degrees, we have how many radians in one complete rotation? 2 pi radians. All right, that means 360 degrees is equal to 2 pi radians. That means 1 degree is equal to how much? 2 pi by 360. That is pi by 180 radians. All right, 1 degree is equal to pi by 180 radians, and 1 radian is accordingly equal to 180 degree by pi degrees. All right, so let me convert this angle first. This is 32 degrees and 45 minutes. That means 45 by 60, that is 0.75. That means it is 32.75 degrees. All right, let me write degree sign over here. I converted these minutes, 45 by 60, that was 0.75. Then I may write this angle is equal to 32.75 degrees. All right, so I'll convert this 32.75 degrees into radians. That means if 1 degree is pi by 180 radians, 32.75 is equal to pi by 180 multiplied by 32.75, which by calculations is equal to 0.5713 radians. All right, so my included angle C is equal to how much? 0.5713 radians. Now let's calculate the area. Now area is 1/2 of one side, that is how much? 123.462 multiplied by B, that is how much? 105.235, and sine of C in radians, it is how much? 0.5713. By calculations, area is equal to 3515.53 meter square. All right, so we completed the first part of the question. Calculate the area of the triangle. So the area of the triangle is equal to 3515.53 square meters. Now the second part of the question says, and the standard error. Now we have to calculate the standard error. Let me rub it first. We're trying to solve as many questions as possible. All right. So now the second part of the question says to compute the standard error. We know that area is given by this formula. All right. Now using the same equation by which we compute the effect of the errors on the observed quantities, and how do we calculate the combined effect? The combined effect of the errors of the observed quantities on the computed or derived quantity is found by differentiating with respect to each of the observed quantities and then summing them up to obtain the total effect. We'll do the same thing. That means standard error in area we have to calculate. That means sigma A square is equal to, let me differentiate it first with respect to one side. This is how much? It is 1/2 of AB sine of C, isn't it? Standard error in this side, square of it, plus same thing. Then we'll go on differentiating with respect to B, 1/2 of AB sine C, standard error in the side B, square of it. All right, sigma A square is equal to how much? This will be equal to 1/2 of B sine C sigma A square of it, and this will be 1/2 of A sine C multiplied by sigma B square of it. All right, so sigma A square, if I take this and this common, it will be how much? Or sigma A will be 1/2 of sine C and square root of square, and from this it will be A and sigma B square. All right, so this is the expression that the standard error in the area in this case will be given by 1/2 of sine C and square root of B multiplied by sigma A plus A multiplied by sigma C, and then their sum. Now we'll go on substituting the values and we'll find our answer. So let me rub it first. All right, so what is the formula for standard error in area? It is 1/2 of sine C square root of B sigma A square of it plus A sigma B square of it. All right, let's substitute the values. 1/2 of sine of, we calculated it in radians, it was 0.5713, right? What is B? How much? 105.235 multiplied by standard error in A, it is 0.030, square of it plus how much is A? It is 123.462 multiplied by how much? Sigma B, 0.020 square of it. All right. So sigma A is equal to 1/2 of value of this is 0.5407 multiplied by square root of this is equal to 9.966 and this one is 6.097. All right, so sigma A is equal to 0.27035. This is 16.063. My calculation standard error in area is equal to plus minus 1.083 square. All right. It is plus minus 1.083 meters square. So we completed both the parts of the question. We calculated the area of the triangle as well as the standard error. All right. Moving on, let's do the next question. All right. Let's do the next question. Question number 2. Question number 2 says that measurements of a line were taken 10 times with a steel tape and were found to be as under. 10 measurements have been taken with a steel tape and the measurements read as follows. All right. What we are being asked to do, assuming that the measurements have been corrected for all the systematic errors, we have to determine the standard deviation, the standard error of the mean, 95.5% error, most probable value, and the most probable error. All right. So is the question. Let me read it again for you. Measurements of a line were taken 10 times with a steel tape and found to be as follows. Assuming that the measurements have been corrected for all the systematic errors, we have to determine the standard deviation, the standard error of the mean, 95.5% error, most probable value, and the most probable error. All right, so let's do this question. Let's make a table. Serial number, measured length, residual, and square of it. This is the residual or the residual error or the variation. So I made the tables: serial number, measured length, residual, and the square of it. How many measurements have been given? We have been given 10 measurements. Measurements have been taken 10 times. So 1, 2, 3, 6, 7, 8, 9, and 10. What are the measured lengths? Let me write it down. All of these. The first one is 100.54. Every length is in meters. 100.54, 100.56, 100.38, 100.36, 100.39, all right, 100.46, 100.48, 100.32, 100.47, and 100.52. All right, so these are my measured lengths. The measurements have been taken with a steel tape and they are as follows. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right, so these are my measured lengths. Then I have to calculate the residual or the residual error or the variation. But for that, and that is equal to measured length minus mean value or the most probable value. But first I have, that means my task number 1 is to find the mean value, the arithmetic mean of all these 10 measurements. And by calculations, that is equal to 100.45 meters. All right, so this is my mean value. I may write it over here. This is my mean value. So next task is to find the residual or the residual error or the variation, that is equal to measured length minus the mean value. All right, so in some cases it will be positive and in some cases it will be negative. All right, what we have to do in each case, we have to subtract the mean value from every measured length. All right, so by calculations, that the first one comes equal to, let me write it over here, residual is equal to measured length, that is this, and we have to subtract mean value from it. So in the first case, it will be 100.54 minus 100.45. all right, so that is equal to plus 0.09. In next case, it will be 100.56 minus 100.45, and that is plus 0.11. In the same way, I may write down the residual values. This comes equal to minus 0.07, because in this case it was 100.38 minus 100.45, so this is minus 0.07. Likewise, this is 0.09 minus, this is minus 0.06. Then we have the value of plus 0.01, then plus 0.03, then we have minus 0.13, then plus 0.02, and lastly we have plus 0.07. all right, so we have calculated the residual or the residual errors in each case, wherein the residual is equal to the measured length minus the mean value. All right, now we have to do the square of these residuals. This is the square of the variation. All right, so by calculations, this is equal to 8. First one, square of it, square of every term. 8.1 multiplied by 10 raised power minus 3. The second one is 12.1 multiplied by 10 raised power minus 3. 4.9 multiplied by 10 raised power minus 3. Next we have 8.1 multiplied by 10 raised power minus 3. Then we have 3.6 multiplied by 10 raised power minus 3. Next one is 0.1 multiplied by 10 raised power minus 3. Then we have 0.9 multiplied by 10 raised power minus 3. 16.9, 0.4, and 4.9. all right, so we have calculated the square of the residual error, and by calculations, its summation of these squares is equal to 60.00 into 10 raised power minus 3. all right, so this is the question, and we have calculated the mean value, and likewise we calculated the summation of the v square, which came equivalent to 60.00 into 10 raised power minus 3. Now let's proceed to what question asks and demands. The first one is that we have to calculate the standard deviation. all right, let me rub it first. I showed you how do we calculate this. Now let's move on to the question and what it asks us to do. All right, So the first part of the question is to calculate the standard deviation. Standard deviation. How do we calculate standard deviation? By its formula, standard deviation or sigma is equal to summation of v square divided by n minus 1. All right. Standard deviation has a formula, square root of summation of v square divided by n minus 1. So let's find it out. So sigma is equal to summation of v square. We calculated it as 60 into 10 raised power minus 3. All right. The square of the sum of the residual errors or the variations, it was equal to 60 into, as we calculated, 60 into 10 raised power minus 3 divided by n minus 1. How many measurements have been taken? 10. So n minus 1 is 9. All right. So by calculation, sigma is equal to plus minus 0.08 meters. So the first part of the question is complete. To calculate the standard deviation, we calculated it and it was found to be equal to plus minus 0.08 meters. Secondly, we have to calculate the standard error of the mean. Standard error of the mean. Standard deviation is same as standard error. And the standard error of the mean is given by sigma m. It is plus minus under root of summation of v square divided by n into n minus 1. All right, so sigma m will be equal to plus minus. How much is my summation of v square? It is 60 into 10 raised by minus 3. 10 measurements have been taken, so it's 10 multiplied by 10 minus 1, that is 9. All right, so by calculations, standard error of the mean is equal to plus minus 0.025 meters. All right, so the second part of the question is complete as well. Standard error of the mean, we calculated it and it is equal to plus minus 0.025 meters. Let me rub it first and do the next parts of the question. All right, now what does it ask? We have to calculate the 95.5% error, all right, which is also expressed as E95.5, or we write it as it is 95.5% error. And you know that it is equal to how much? It is equal to plus minus 2 sigma. All right. That means it's plus minus twice. We calculated the sigma or the standard deviation. It was equal to how much? It was 0.08 meters. So by calculations, my E95.5 or 95.5% error is equal to plus minus 0.16 meters. All right. So this part is complete as well. Next, most probable value. All right. Most probable value. Which is the most probable value? The most probable value is the arithmetic value or the mean value, and which we found equal to, it was how much? It was 100.45 meters. So that becomes my most probable value, is also known as the mean value and is equal to the arithmetic mean in a given set of measurements. All right, and the chances of that value is more likely to be equal to the true value. All right, the arithmetic mean value, which is also known as the most probable value or the mean value, has more chances than any other value to be equal to or to be near or mostly equal to the true value in any given set of measurements, because we cannot find the true value. That is a hypothetical quantity. True value is that value which is absolutely free from every measurement errors, but that is not possible to determine because errors always creep in measurements, and it's nearly impossible that we can have a true value. Why? Because there are human limitations, the limitations of the surveying instruments, etc., and how our errors make the effect on the quantities. That is, so likely we take the most probable value, which is mean value, which in a given set of measurements is equal to arithmetic mean. We take that as the most probable value, and the chances of this most probable value of being true value are quite high. This value has more chances of being the true value than any other value. All right, so this is the most probable value and in a given set of measurements, it's given by arithmetic mean, and it's equal to 100.45 meters. So last part of the question says we have to calculate the most probable error. All right, so let's calculate the most probable error. And I'm time and again saying that please do not confuse yourself with the most probable value and the most probable error. Most probable value is equal to arithmetic mean, or the mean value in a given set of measurements, but the most probable error is something else, and it is equal to how much? 0.6745 times the standard deviation. All right, it is 0.06745 times the standard deviation, and it is 0.6745. How much is my standard deviation? My standard deviation is equal to 0.08. So by calculations, this most probable error is equal to plus minus 0.054 meters. Plus minus 0.054 meters. So we calculated everything. We calculated the standard deviation, the standard error of the mean, the 95.5% error, most probable value, and the most probable error. Moving on, let's do the next question. All right, question number 3. Question number 3 is determine the relative precision in the case of 10 measurements of a line which have been given below. 10 measurements of a line have been given below. We have to determine the relative precision. I'll tell you how we calculate this. Again, we'll be making a table. Serial number, measured length, or the measured value. All right. Then we have the variation, or the residual error, or the residual, and then square of it. All right. So how many measurements have been taken? 10. Measured value. These are the measured values. I'll write it down. The first one is, every measured value has been taken in meters. First one is 45.850. Next one, 45.856. Next one is 45.851. Then we have 45.852. The next one is 45.853. Then we have 45.854. Then comes 45.853. Then we have 45.852, 45.856, and lastly we have 45.851. All right, so these are the measurements which have been taken, and we have to calculate the relative precision. First, I'll calculate the first task is to calculate the mean value, which is equal to arithmetic mean of these 10 set of measurements, and by calculations that is equal to 45.853 meters. All right, so the mean value or the most probable value is equal to 45.853 in this case. And how do we calculate the arithmetic mean? Sum of all the observations divided by number of observations. That means sum of all divided by 10. All right, so the first part is complete. Next, we'll calculate the residual or the variation, that is equal to how much? Measured value minus the mean value. That means every measured value, from every measured value I'll be subtracting the mean value and I'll get my variation, as we did in the previous question. So I may write it down. The first one is 0.003. Next one is plus 0.003. Then we have minus 0.002, minus 0.001. All right, then we have 0 because 45.853 and subtracted from the mean value itself is 45.853, that is 0.00. The next one is plus 0.001. Then we have again 0 because the measured value and the mean value are the same, 0.00. Then comes minus 0.001. Then is plus 0.003. And lastly, we have minus 0.002. All right. Then the next step of the question is to calculate the square of the variations. In each case, I'll have to calculate the square of it. The first one is, this is v and this is v square. 9 into 10 raised power minus 6. Then we have again 9 into 10 raised power minus 6. Then 4 into 10 raised power minus 6. We have 0, then we have 1, then we have again 0, because here it's 0. After that we have again 1, then we have 9, then we have 4. All right, so we calculated the square of the variation in each case. Now our next task is to calculate summation of it, summation of v square, sum of all of them, and by calculations that is equal to 38 into 10 raised power minus 6. 38 into 10 raised power minus 6. All right, so we calculated the summation of v square, we calculated the mean value. Now let's move on. Let me rub it first. All right, I had to calculate we have been asked to determine the relative precision. And you know that relative precision is equal to how much? Relative precision is given by, it's a ratio between standard deviation and the mean value. Mean value I calculated, it was equal to 45.853. So the thing which needs to be calculated is the standard error of the mean. All right, we have to calculate the standard error of the mean. So standard error of the mean is equal to how much? It is given by sigma m, and it's equal to plus minus summation of v square divided by n into n minus 1. And we calculated the summation of v square, which is equal to 38 into 10 raised power minus 6. All right, how many measurements have been taken? 10 measurements have been taken, so it's 10 into 9. By calculations, standard error of the mean is equal to plus minus 0.00065 meters. Now what will be my relative precision? Relative precision is standard deviation of mean or standard error of mean, which is 0.00065 divided by mean value of the measurement, that is equal to 45.853 arithmetic mean value, or the most probable value, or the mean value. By calculations, as we always express our numerator as unity, it is equal to 1 by 70543, but we always round off our denominators, so it is equal to 1 by 70500. So this is my relative precision. All right, we had been asked to calculate the relative precision in case of 10 measurements of a line, which were given below, and that is how we calculated it. All right, relative precision is equal to the ratio of the standard deviation, or the standard deviation of the mean, by the mean value of a measurement. All right, moving on, let's do the next question. All right, this is question number 4, and the question number 4 says the length of the baseline of a triangulation survey was measured 6 times and the following values were obtained. All right, the length of the baseline of a triangulation survey was measured 6 times and the following values were obtained. We have to determine the standard variation, the probable error of a single observation, the probable error of the mean, and the most probable value. All right, so let's do this. The length of baseline of a triangulation survey was measured 6 times, and we have to calculate certain values like standard deviation and other values. All right, so let's do it. In the same case, I'll be making a table wherein I'll be having my serial number, my measured values, then comes the residual, and lastly the square of the residual. All right, how many measurements have been taken? 6 measurements have been taken. All right, and the measured values are written over here. Let me write it down over here. Every measured value has been taken in meters. So the first one is 143.26 meters. Next one is 143.23 meters. Third one is 143.24 meters. The fourth one is 143.22 meters. Fifth one is 143.25 meters, and the last one is 143.24 meters. All right, these are the values of the baseline of a triangulation survey, which were measured 6 times, and the following values were obtained. We have to calculate the standard variations and the probable error of a single observation, probable error of the mean, and the most probable value. All right, so the first task is to calculate the mean value, which is arithmetic mean of the set of 6 measurements, and by calculations that is equal to 143.24 meters. All right, so this is my mean value or the most probable value. All right, the next task is to calculate the residual, which is equal to measured value minus the mean value. So I have to subtract mean value from the every measurement, and I'll be getting my residual or the residual error or the variation. And let me do it. The first one is plus 0.02. Next one is minus 0.01. Then we have 0. Why? Because the measured value and the mean value are same. 143.24 minus 143.24. It's 0. Then we have minus 0.02. Then plus 0.01. Then again 0. Because measured value and the mean value are same. Alright. The next task is to calculate the square of the residual. We have to square each value. The first one is equal to 0.4 into 10 raised power minus 3. Next one is 0.1 multiplied by 10 raised power minus 3. Then we have 0. Then we have 0.4 into 10 raised power minus 3. Then we have 0.1 into 10 raised power minus 3. And then obviously 0. After that, our task is to calculate the summation of v squared. That means we have to calculate the sum of all of these values, and which by calculations is equal to 1 into 10 raised power minus 3. Alright. It is equal to 1 into 10 raised power minus 3. So let's move on. Let me rub it first and we'll find the values that we have been asked to calculate. Alright. The first one is to calculate the standard variation. The standard variation is the same as standard deviation. It's one and the same thing. Standard, we call it standard deviation or standard variation. First one, sigma. It is equal to plus minus summation of v squared divided by n minus 1. Alright. So sigma is equal to plus minus. I calculated summation of v squared was how much? 1 into 10 raised power minus 3. N minus 1. How many measurements have been taken? 6 measurements have been taken. So n minus 1 is 5. By calculation, sigma is equal to plus minus 0.014 meters. So we calculated the first part. Second part is asking us to calculate the probable error of a single observation. The probable error of the single observation is equal to most probable error. Probable error probable error of single observation, it is equal to probable error is equal to how much? It is plus minus 0.6745 times sigma. It is the most probable error, or we call it probable error of single observation, and it is equal to plus minus 0.6745 times the sigma. So by calculations, it is plus minus 0.6745 times our standard deviation or the standard variation, that came equivalent to 0.014. So by calculation, this is equal to plus minus 0.0094 meters. So this is the probable error of the single observation. It is 0.0094 meters. Next, it asks us to calculate the probable error of the mean. We know that probable error of mean is equal to how much? Probable error of the mean is equal to probable error in the single observation divided by square root of n. Because we know that probable error of the single observation is plus minus 0.6745 times summation of v square divided by n minus 1. While as the probable error of the mean is given by plus minus 0.6745 multiplied by summation of v square divided by n into n minus 1. So mean is equal to probable error of the mean is equal to probable error of the single observation divided by. All right, so I'll use the same formula. I have to calculate the probable error of the mean. Probable error in the single observation is plus minus 0.0094 meters divided by square root of n. How many measurements have been taken? 6 measurements have been taken. Under root of 6. By calculations, this is equal to plus minus 0.0038 meters. All right, so the probable error of the mean is equal to plus minus 0.0038 meters. And the last part of the question says that calculate the most probable value. We have already calculated it. The most probable value is equal to the arithmetic mean, and that is known as the mean value or the most probable value, and that was equal to how much? It was 143.24 meters. So this is the most probable value or mean value or arithmetic mean, which we already calculated. It was 143.24 meters. So we have calculated all the parts of the question. All right, so moving on, and let's do the next question. We're trying to solve as many questions as possible. We are doing the same in each and every chapter. All right. So let's move on and do the next question. All right. This is the question number 5. And the question number 5 says, in carrying a line of levels across a river, the following 8 readings were taken with a level under identical conditions. These were the values. We have to calculate the probable error of the single observation and the probable error of the mean. All right. So let's do this question. We have been asked to calculate the probable error of the single observation and the probable error of the mean. All right. So again, I'll be making a table, serial number, staff readings, then the residual and square of the residual. All right. How many readings have been taken? 8 readings. All right. 8 readings have been taken, and the staff readings have been given as these. I may write it down. Every measurement has been taken in meters. First one is 2.322. Next we have 2.346, 2.352, 2.306, 2.312, 2.300, 2.306, and 2.326. These are the readings which have been carried out. All right, while measuring the levels across a river, these 8 readings have been found by a level under identical conditions. These are my staff readings, and the first task is to calculate the mean value. Mean value by calculations is equal to 2.321 meters. probable value or the most probable value or the mean value is equal to 2.321 meters. Next, I have to calculate the residual. That means I have to subtract this mean value from every staff reading. First, I'll be having plus 0.001, then plus 0.025, then it is plus 0.031, then minus 0.015, minus 0.009, then the value is minus 0.021, then minus 0.015, and lastly the value is plus 0.005. I have calculated the residuals or the residual errors or the variations, which is equal to measured value minus the mean value. So I subtracted mean value from every staff reading, which we have obtained by carrying a line of levels across a river, all right? And these 8 staff readings have been taken under identical conditions. I calculated the residual error as well. Then now the next task is to calculate the square of the residuals or the square of the variations. First one is 0. All right, next one is third value is next. Last value is, all right, so I calculated the square of the variation. Now the task is to calculate the summation of these square, in which by calculation the summation of all of them is equal to 0.002584. I calculated the mean value, I calculated the summation of p square. Let me rub it first and let's move on. All right. First part of the question, calculate the probable error of single observation. Probable error of single observation is equal to how much? Probable error of the single observation is given by plus minus 0.6745 times sigma, that is summation of p square divided by n minus 1. So probable error of single observation is equal to plus minus 0.6745 summation of p square. I calculated it. It was equal to 0.002584 divided by n minus 1. How many readings were taken? 8 readings were taken. So n minus 1. That means probable error of the single observation. Probable error of the single observation is equal to plus minus 0.6745. By calculations, this is equal to 0.0192. That means my probable error of the single observation is plus minus 0.01295 meters. All right. Probable error of the single observation or the probable error of the observation is equal to plus minus 0.01295 meters. Second part of the question says us to calculate the probable error of the mean. And you know how the two are related. Probable error of the mean is given by probable error of the single observation divided by square root of n. So probable error in single observation is plus minus 0.01295 meters divided by square root of n. How many readings were taken? 8 readings were taken. So by calculations, this is equal to plus minus 0.00458 meters. So I completed both the parts of the question. I calculated the probable error of the single observation, which came equivalent to 0.01295 meters, and I calculated the probable error of the mean, which came equivalent to plus minus 0.00458 meters. So we completed both the parts of the question. With this, I conclude this video lecture. Thank you for watching.